Look up at the night sky. What do you see? Thousands of twinkling stars like tiny diamonds scattered across a black velvet cloth. Each one of these stars has its own story, its own journey through the cosmos. Each one of those stars is a giant ball of burning gas, a colossal furnace producing an incredible amount of light and heat. These stars are the powerhouses of the universe, their energy driving the very fabric of space and time. These celestial giants are not eternal. They have a life cycle just like everything else in the universe. From their fiery birth in stellar nurseries to their eventual demise, stars undergo a fascinating transformation. They are born, they live, and eventually they die. The birth of a star begins in a nebula, a vast cloud of gas and dust. Over millions of years, gravity pulls this material together, igniting nuclear fusion in the core. Some stars fade away quietly, gently expelling their outer layers into space. This process creates beautiful planetary nebulae, glowing shells of ionized gas that light up the surrounding space. Others, however, meet a far more dramatic end. They explode with the energy of 1 billion suns, illuminating the cosmos with a blinding flash. These cataclysmic events are known as supernovae. These are the supernovae, the most powerful explosions in the universe. They not only mark the end of a star's life, but also seed the cosmos with heavy elements, essential for the formation of planets and life itself. The remnants of these explosions can form neutron stars or even black holes, continuing the cycle of cosmic evolution. Stars are born in vast clouds of gas and dust scattered throughout galaxies. These immense clouds, often spanning light-years across, are the cradles of stellar creation. These clouds, known as nebulae, are the stellar nurseries, the birthplaces of stars. Nebulae come in various shapes and colors, often illuminated by the light of nearby stars, creating breathtaking cosmic vistas. Gravity, the force that makes things fall to the ground, plays a crucial role in star formation. It acts as the invisible hand that orchestrates the dance of particles within these nebulae. It pulls the gas and dust in a nebula together, squeezing the cloud tighter and tighter. Over time, this gravitational pull causes the cloud to collapse under its own weight. As the cloud collapses, it gets hotter and hotter. The increasing pressure and temperature at the core of the cloud ignite a series of complex reactions. Eventually, the temperature at the center becomes so intense that nuclear fusion begins. This process is the heart of a star's life, where hydrogen atoms are fused together. Hydrogen atoms, the simplest and most abundant element in the universe, fuse together to form helium, releasing an enormous amount of energy in the process. This energy radiates outward, and a star is born, shining brightly in the vast expanse of space, marking the beginning of its long and luminous journey. A star's life is a constant struggle between two opposing forces, gravity and the outward pressure generated by nuclear fusion. Gravity wants to crush the star, pulling all of its matter towards the center. The outward pressure from fusion, on the other hand, wants to blow the star apart. For most of a star's life, these two forces are in equilibrium, locked in a delicate balancing act. This balance is what keeps the star stable, allowing it to shine brightly for millions or even billions of years. However, this balance cannot last forever. A star's fuel source, the hydrogen in its core, is finite. Eventually, the star will run out of hydrogen to fuse. When this happens, the outward pressure from fusion weakens. Gravity, relentless and unforgiving, begins to gain the upper hand. The star's core contracts, becoming denser and hotter. The increasing temperature ignites the fusion of helium, the product of the previous fusion reactions. Helium fuses into heavier elements like carbon, oxygen, and neon, releasing more energy and temporarily staving off the star's collapse. The iron crisis, a star's fatal flaw. The star has bought itself some time, but its fate is sealed. The fusion of heavier elements produces less and less energy. Eventually, the star's core is filled with iron, the most stable element in the universe. Iron is a star's kryptonite. Fusing iron does not release energy. Instead, it requires energy. This is a crucial turning point in the star's life. With no more fuel to burn and no more energy to produce, the star's core can no longer withstand the relentless crush of gravity. The collapse gravity's final victory. The core collapses in on itself at an astonishing speed, reaching millions of kilometers per hour. The collapse happens so quickly, it's like a house of cards collapsing under its own weight. The outer layers of the star, no longer supported by the core, rush inward, crashing into the incredibly dense core. This violent collision sends shock waves rippling through the star. These shock waves carry an immense amount of energy, far more than the star has ever produced in its entire lifetime. The rebound, a spectacular explosion. The shock waves, traveling at nearly the speed of light, race outward, tearing the star apart from the inside out. The star explodes with unimaginable violence, releasing a blinding flash of light and a torrent of energy that can outshine an entire galaxy. This is a supernova, the cataclysmic death throes of a massive star. The explosion hurls the star's outer layers into space at incredible speeds, seeding the surrounding interstellar medium with heavy elements forged in the star's core. Supernovae, cosmic fireworks. Supernovae are the universe's most spectacular fireworks displays. They are incredibly bright, sometimes visible even during daylight hours on Earth. Ancient astronomers witnessing these celestial events were awestruck by their brilliance and mystery. They believed that new stars were being born, but we now know that supernovae mark the end of a star's life. The aftermath, recycling, and rebirth. Although supernovae signal the death of a star, they also play a crucial role in the cycle of life and death in the cosmos. The heavy elements scattered by supernovae, like carbon, oxygen, and iron, are the building blocks of planets, moons, and even life itself. The shock waves from supernovae can also trigger the formation of new stars by compressing nearby clouds of gas and dust. Section 10. Conclusion. The circle of life and death in the cosmos. Supernovae are a testament to the incredible power of the universe and the intricate cycle of stellar evolution. These cosmic events are not just random explosions, they are the result of a star exhausting its nuclear fuel and collapsing under its own gravity. This collapse triggers a massive explosion, releasing an immense amount of energy and scattering elements across the cosmos. They are the grand finale of a massive star's life, a spectacular explosion that marks both an ending and a beginning. The remnants of this explosion can form new stars, planets, and even the building blocks of life. It's a beautiful paradox where destruction leads to creation, a cycle that has been ongoing for billions of years. The next time you look up at the night sky, remember the stars. Each one has its own story, its own life cycle, and its own eventual fate. Some will end quietly, while others will go out in a blaze of glory, contributing to the cosmic cycle of life and death. They are not just twinkling points of light. They are dynamic, evolving objects, constantly changing and influencing their surroundings. Their light takes millions of years to reach us, a journey that began long before humans walked the earth. Some stars are destined to end their lives in a blaze of glory, seeding the universe with the elements necessary for life as we know it. These elements, like carbon, Oxygen and iron are the building blocks of planets, plants, animals, and even humans. The circle of life and death in the cosmos is a reminder of our connection to the universe, a cycle that continues to shape the cosmos and everything within it.